friends, welcome to day number 7. Today we're going to just continue on where, if you remember yesterday, we spent some time lighting up some LEDs, and your challenge was to code 3 LED lights to turn on or blink or flash, whatever it is that you came up with. Today we're going to take a look at how to program a code for a buzzer, this little tiny guy right here. In order to do that, I just decided to keep this because we're going to use it probably in another project here coming up very shortly. I happen to have 2 breadboards. You could just program this right onto that same breadboard. You don't have to take these off to do the activity today. I'm just using a new breadboard just so it's a little bit cleaner on this interface here for you. So what we're going to be doing here is we're going to be continuing on in the Raspberry Pi project of the LEDs, buzzers, and scratch games, and kind of just breaking that one down to be respectful of your time. We know you don't have endless hours every day. And so today, we're going to be taking a look at how to make some noise with these buzzers. And so the first thing that we want to do today is we're going to go back into Scratch. And if you remember yesterday, we went down to the extension block down here. I'm going to go ahead and expand this just a little bit more, maybe. Down here in the bottom left-hand corner, and when we clicked on that yesterday, we had these different Raspberry Pi extensions. We had yesterday installed the Simply Electronic one, and you can see that little LED icon right here. That allowed us to program lights. Well, we need to install this one today, the Gpio Pins. Remember, that stands for General Purpose Input Output. And we're going to go ahead and install that. And what you're going to see here is that actually we have 4 blocks that look pretty similar to the LED ones, except for now they're more just general purpose blocks. You can see that it's a GPIO pin versus an LED, and they're going to allow us to program things like high or low, kind of thing like in binary, 1 or 0, or on, off, whatever makes sense for you there. So once you have that installed in your Scratch programming, let's go ahead and wire up the buzzer. Okay, so let's take a look at this little tiny buzzer. It's similar to an LED, and you may run into this sometimes, where if you're looking at mine here, the legs are the same length. But buzzers, for the most part, are just like LEDs. They have to have a positive power supply going to the longer positive leg to work. Well, my legs are the same, so what am I going to do? It's probably really hard to see here, but on the top of mine, there's actually a plus sign to indicate that that's the positive leg. So oftentimes you'll see that happen, and LEDs will do the same thing. If the legs are the same, then there's usually a notch, which I'll show you in a future video so you can determine which leg is the positive. So I'm going to go ahead and I'm going to plug this in now. I'm just going to plug this in, if you want to follow along, on 10, and I think it takes me from 10 and then looks like 11, 10, and 13. So there's a little bit of a space there. And I've got that right here, and I can see that my positive is on the top side. And we're going to do something very similar. I don't have to add wires to this, but if I needed some space, I could add some male to female wires and have that buzzer sit out further. I don't need that for this particular project. And the other thing is buzzers are a lot more sturdier than LED lights, so we don't have to worry about a resistor for this one either, which is really nice. So we're going to use 2 male to female leads here, and we're going to go ahead and plug these in. One is going to go to the ground. So the ground, if you remember, is going to be our negative side, okay? And our positive is going to go to one of the GPIO pins. And we're just going to use 17 again because that's what we used yesterday for the LED, just to keep it similar. You can kind of see how these things work here. So I'm going to go ahead here and get this wired in. I'm going to use, in this case, I'm going to use brown for my ground, which is the negative. Remember, these things run horizontal here, so I know I'm in row 13. There's 10, 11, 12, there we go, 13. And I know my ground, if you remember from yesterday, is the 3rd GPIO pin down from the right column of the Raspberry Pi. Remember, the first 2 are both 5 volts, and we don't want to do that. And then my positive, okay, is on the breadboard, number 10, and I'm going to add this to 17, which is the 6th one down. So on the left-hand column, 1, 2, 3, there's 4, 5, 6. Okay, now nothing's happened here yet because we don't have anything going on. So we need to go here and dive into the code. So let's go ahead and do that here. So we're going to start it off looking just almost like what we did yesterday with our programming. We're going to go here to events. We're going to use the green when the green flag is clicked. We're going to toss in here right away a forever block. So in our control, we've got forever. Actually, you know what? Let's not do forever. Let's do repeat so it doesn't go on forever. And in there, we're now going to go to this new extension, this Raspberry Pi Gpio, and you can see we've got some of these blocks here. It looks just like the LED, so you start to see some connection here. Like, man, this looks just like yesterday. You're absolutely right. So we're going to go ahead and we've got to set our Gpio pin. So I'm going to go ahead and drag this over. And we know that we are on pin 17. So we'll choose 17 here. Okay, we'll make that high. And then we're going to add a wait block so we can have a little pause in the beats here. Okay, and then we can just go ahead and we're going to set the same block here. I'm going to right click this and duplicate this so I don't have to redrag twice. There we go. And what I'm going to change here then, as opposed to high, we'll go low. Let's go ahead and test this here and see what this looks like. I don't know if you can hear this or not, so I'm going to try to move this over. It's real faint. It's not very loud, but we've got it, and I maybe even need to get a better buzzer for this going forward. Basically, it's just going, just doing that back and forth, and we did it for 10 times with our repeat block there. So now we can kind of mess around with this a little bit more, and we can change what this sounds like. We can change then different frequencies and kind of make our own beats. And so on the Raspberry Pi project, it kind of gives you this example. So we're going to go ahead and do the same thing. We'll just so you can kind of hear this and see what it's like. So they suggest making this 5/100ths of a second. So 0.05. All right. And then this wait block, they do something really cool. They add one of these operator blocks, which I just love. You can do so many awesome things with this. And there's actually a pick random. So we can drag this pick random block into where we've been typing in data if you've never done this before. And now we can have this change. And we're going to go from 0.1 to 0.2. So we're going to get a mix. It's going to pick random times here. All right. And we'll just go ahead and continue to build out some of this code here. So what we're going to do is we're actually just going to copy this right here. So I'm going to right click on this Gpio pin, first one. I'm going to select duplicate. Let me get this big old block. All right. And now what I'm going to do here is we got after that, I want to get this out of here. Let's see. I want to go down underneath it. Like so. We're going to make this a repeat of 4. We're going to add a control of forever. So it'll run this the whole time until we actually turn it off. And then we're going to slide this inside here. Oh, we got it all confused here. Let's try this again. This goes in this repeat. That repeat goes in that forever. There we go. And then this sits underneath that repeat of 4. Okay. And then they actually have another set of this. So I'm going to duplicate this one more time. And I'm going to stick that down here. And then what they've done for this is they've made this one 0.6. So we're going to remove this random block. We don't need that. So we will make this 0.2. Then they did a 0.3. And then we'll get rid of this random. We'll make that 0.2. All right, so now when we run it, again, I don't know if you can hear it very well. I'll try to get this closer. And you can definitely hear it on yours probably better. And you can play around with this here, but you're starting to see how we can use weight blocks and high and low to go ahead and kind of make our own little beats on these little buzzers. You know, nothing real fancy, but it really kind of makes you do some cool things once you start to explore this, and using just a very cheap type output of a buzzer, we can start to do some really cool things, especially when we think about game application. Could we create this to kind of go faster when we're closer, or maybe slower when we're farther away from an object? And I mean, there's lots of cool things we're going to be able to do here in the upcoming projects. So what we're going to do now then is, in the next video, once you kind of play around with that, tinker, make your own little beat, and I would love to hear it over on the Slack channel. Go ahead and upload what you've created for your own little music beat. And in the next project, we're going to take a look at combining our buzzer with our 3 LED lights and start to bring some of those things all together, and also start to figure out how we can streamline our wires. So we haven't even looked at the power rails of the breadboard yet, and we're going to take a look at how we can use these to reduce how many wires are all over the place. So good luck making your beats. Have some fun there, and we will see you in the next video once we hear your own little music beats over on the Slack channel. All right, my friends, stay awesome.